Hello, welcome to a video on the last page of the section 5.5 notes. Here we're going to talk about example 3, which is comes from the 2002 AP exam, Form B, number 4, free response. So here we have a graph of a differential function, which is called f, and it's graphed on the closed interval from -3 to 15. And has a horizontal tangent x equals 6, so that pretty much would imply that f prime of 6, of course, would be 0. And then g of x is defined in this manner. It's 5 plus the definite integral from 0 to x of f of t times dt, for, using the same closed interval from -3 to 15. Now, if this is true, we could say that g prime of x will just equal f of x, because the derivative of 5, which is a constant, 0, and the derivative of a definite integral, according to FTC part 1, is that we just wind up getting f of x. Now for g of 6, that's simply just going to be, for part A, which I'll do down here, it's going to be 5 plus the integral from 0 to 6 of f of t times dt. So in this case, what we're trying to do is we're trying to find the area from 0 to 6. The problem is I have no idea what that's going to be because I don't know the equation for this function. So in this case, actually, we're kind of clueless because we can't find the area. And the reason why we can't find the area don't know the function, and plane geometry doesn't work for us here because I don't know what shape that is. So we won't worry about that one. But g prime 6 is simply going to be f of 6 using FTC, that relationship we just made over here. And of course, that's 3. And then g dou prime of 6 is going to be f prime of 6, since we're taking the derivative again. And we know it's 0 since we have a horizontal tangent there. So at least these two we could do, though that one I couldn't do. For part B, you're asked on what intervals is g decreasing. Justify your answer. So g is decreasing when g prime is negative. That's something that we should know. And if g prime is decreasing, then f is going to be negative. Well, where is f negative? So if g is decreasing, g prime is negative, or f is also negative. And that's going to be negative from -3 to 0 and 12 to 15. That's how we justify it. And then what intervals is it concave down? So g is concave down when g dou prime is negative, or f prime is negative. Well, f prime is going to be negative when you have tangent lines of negative slope, which looks like it's going to start happening from 6 to 15. So that's from 6 to 15. Whether we do open or close, I'm not going to really care because AP just tells you to use an open interval, so I'm not going to really care so much about that. Then lastly, find a trapezoid approximation from 3 to 15 using 6 subintervals. Well, and I think they have to be equal with, delta t equals 3. So remember, area of a trapezoid is this, 1/2 times b1 plus b2 times the height, right? So the height here is going to be like our delta t, which is 3. So if I were to draw this, So we're going from 3. Actually, I think that was supposed to be negative 3 to 15. My bad. Not 3 to 15. Because that wouldn't make sense if delta t is 3. Because remember, our delta x, or in this case delta t, is b minus a over n. 15 minus negative 3 over 6. Yeah. So anyway. So what we're doing is we're drawing these trapezoids here. With that right there is going to be our height. And of course, the y values act as b1 and b2. So if you remember, the way we find this area is 1/2 times my height. And then we're going to use the first y value once, f of negative 3, plus 2 times f of 0, plus 2 times f of 3, plus 2 times f of 6, plus 2 times f of 9, plus 2 times f of 12, and then the last one, f of 15 just once. So that's how I would go about doing that. So there it is right there. And remember, we have to do the y values twice except for the first and last one, because the first and last y values are used as a base just once for our trapezoidal rule. I don't know what the y values are exactly for some of these. It's not very clear. Actually, you know what? It is clear. I lied. I know f of negative 3 is negative 1 plus 2 times 0 plus 2 times 1. F of 6 was 3. F of 9 is 1. Yeah, there's a sense of symmetry here. It's 1/2 times 3. And that's going to be negative 1 plus 0 plus 2 plus 6 plus 2 plus 0 plus negative 1. Negative 1, 2, and negative 1 cancel. So it's 1/2 times 3 times 8, which is 12. And I think that kind of covers it. Yep. So there we go. Okay, that concludes the video.